Lesson 5-2, Adding Exponents. Objective: I can simplify expressions with like bases. Essential question: how do I simplify expressions with like bases? Let's refer to our formula chart. Product of powers is adding exponents. A to the m times a to the nth power equals a to the m plus n power. And let's go over our powers. So the 3 is the base, the little 4 is your exponent. The multiplicity of this 3 is 4. So if you're to write out the factors in expanded form, it would be 3 times 3 times 3 times 3. You would read this as 3 to the 4th power. Example 1. Adding exponents with two like bases. So we have x to the 7th power times x to the 5th power. Using our property, our product of powers, we have x to the 7 plus 5 power. 7 plus 5 is 12. So our simplified expression is x to the 12th power. Example 2. Adding exponents with three like bases. 7 to the 6th power times 7 to the 5th power times 7 to the negative 4th power. Well, just like the previous example, we're going to combine the exponents together. So 6 plus 5 minus 4. 6 plus 5 is 11. 11 minus 4 is 7. So we have 7 to the 7th power. And that's our simplified expression. Example 3. Applying product of powers to different bases. 2 times a to the 1/2 power times 3 times b to the 1/3 power times a to the 1/2 power times 5 times b to the 2/3 power. The first thing you want to do is try to simplify what's on the inside of the parentheses. A and b are different bases, so we can't do anything with those, but we can multiply 2 times 3, which is 6. So we're going to write 6 a to the 1/2 power times b to the 1/3 power. Notice I didn't write the dot. If you have nothing in between variables, it's assumed to be multiplication. And we'll put the 5 in the front for this one. A to the 1/2 times b to the 2/3. Okay, the next thing you want to do is put the like bases together. So rewrite it, writing the a's together, the b's together, the constants together. So we're going to have 6 times 5 times a to the 1/2 power times a to the 1/2 power times b to the 1/3 power times b to the 2/3 power. Okay, the next step would be to combine the exponents and multiply the 6 times 5, which is 30. So we're going to have 30 times a to the 1/2 plus 1/2 power times b to the 1/3 power plus 2/3 power. Now these have the same denominator, so that means they're like fractions, so you could add them. 1 plus 1 is 2. You leave the name of the fraction alone, so this could be 2 over 2. So this could be 30 times a to the 2 over 2 power times b. 1/3 plus 2/3 is 3/3. You could add those together because, again, they have like denominators. They're like fractions. And when you're adding and subtracting fractions, you only add and subtract the numerator. You leave the denominator alone, because the denominator is the name of the fraction here. So if we were to simplify those fractions, 2 divided by 2 is 1, and 3 divided by 3 is also 1. So our simplified expression is 30AB. Example 4. Apply product of powers to different bases. X squared times y to the 7 halves times 5 x to the 1/2 power times y to the 3/4 power. Well, there's nothing that we can simplify on the inside of these parentheses, so we'll go on to the next step, which is putting the like bases together. When you're writing this, you also want to put it in standard order. That means the coefficient, the constant number, will come first, and then the variables will be in alphabetical order. So for that, we have 5 x to the 2nd power, x to the 1/2 power, times y to the 7/2 power, times y to the 3/4 power. From there, we will use the product of powers to add the exponents together from the like bases. So we have 5 to the x times 5 times x to the 2 plus 1/2 power times y to the 7 halves plus 3/4 power. Now notice that we can't add these fractions together yet because they are not like denominators. So we're going to have to find a least common multiple. So the least common multiple of 1 and 2 is 2. 2 times 1 is 2, so we're going to multiply this fraction by 1 over 1. 1 times 2 equals 2, so we're going to multiply each of these fractions by 2. So let's rewrite that part. 5 times x to the 4 over 2 power plus 4 over 2 plus 1 over 2 power. And then we'll do the same thing with the 2 and the 4 here. The least common multiple of 2 and 4 is 4. 2 times 2 is 4, so we're going to multiply these by 2 to get 4, and we're going to multiply this fraction by 1 to get 4. So we're going to write that times y to the 14 over 4 plus 3 over 4. Combine the like terms here, and then you get your simplified expression. So we have 5x to the 5 halves power times y to the 17/4 power. Notice when we add and subtract the fractions, we only add the numerator, not the denominator. We leave that alone. These fractions cannot be reduced anymore, so that's it. That's our answer. Let's do one more example. Example 5. Adding exponents including variables. 3 to the 2x power times 3 to the x plus 7 power times 3 to the negative 2 power. So these all three have the same base, and so we're going to use the product of powers property to combine all of the exponents together. So let's go ahead and write that out. We have 3 to 2x plus x plus 7 minus 2. We want to combine like terms here. So we're going to circle our x terms. We have 2x and plus x. That's going to be 3x. So we have 3 to 3x, and then let's combine our constants. Plus 7 and minus 2. 7 minus 2 is 5. So our simplified expression is 3 to the 3x plus 5 power. And that is our simplified expression.